Hi and welcome to our pre-calculus. The topic today is proving trigonometric identities using odd and even identities. So this is essentially type 8. We have gone through 1 through 7 and this is just one more in that list. Let me remind you that we have odd even identities here. Excuse me, odd even So you remember that cosine and secant are even functions. That is, if you change the input from positive to negative, they don't change. Cosine of minus u, same as cosine of u. And secant of minus u is same as secant of u. The other four trig functions are odd, meaning if I change the input to its negative, the output also changes to its negative. So 2 are even and 4 are odd, and even functions are symmetric with respect to y-axis, odd functions are symmetric with respect to the origin, and all of those properties. Now we are going to take a look at a few examples of how does this get to be used in the text of identities. So cosecant and sine, both of them are odd. So what does that mean? That means that minus comes out and this minus comes out. So I will have minus cosecant of x, and the other one is plus sine of x. So what did I do? I just used odd even on both of them, and so long as you use the same rule several places, you can just type it once. So we used it. Now I want to go from here to the right hand side, and let's go on paper so that we have a sense of what we are doing, and that's going to be a little bit better. So let's so I go here, and so what we want to show is at that point we are at the level of sine of x minus cosecant of x, and I want to show this is same as minus cosine of x cotangent of x. That's what the identity is. After we have applied the negative angle identities, that's what I have. So how can I go from this to that? I know that cotangent has a sine, is cosine over sine, and this is also sine in the denominator. So maybe that's going to provide me a way to go. So I go ahead and say, well, next step, I write this thing as 1 minus, so let me start again and say that, so I start with sine of x minus cosecant of x, and next I say this is same as, of course, sine of x minus 1 over sine of x. So what did I do here? I used the reciprocal identities. This is reciprocal identities. Next, I take common denominator. So common denominator meaning multiply this thing by sine of x. So I take this one and write it as sine square of x over sine of x. Multiply numerator and denominator by a sine. So here all I have done is algebra. So I have done algebra. Next, numerator 1 minus sine square is cosine square. So sine squared minus 1 is minus cosine square over sine of x. So to come here, we have done Pythagorean. Well, what do I want? I have minus, that's good. I want to separate the cosine, and I want to write the rest of it as cotangent. So I have these three pieces to create. So I come and say, well, I have my minus. I write this cosine separately, and cosine of x over sine of x here. So what I have done from there to here is just algebra. I just wrote cosine squared as cosine times cosine. I have my minus, I have my cosine, and what is cosine over sine? Well, that is by ratio identity. That's just cotangent of x. So here I'm using the ratio identities. So that's the plan of action. So all that is left to do is to to carry this out. And now let's go ahead and where were we? Here, yes. Okay. So I write this thing as I need a fraction. So minus 1 over sine of x, and then plus sine of x. So I am applying reciprocal identities here. I wrote cosecant as minus 1 as 1 over sine. Then I add them up. So I need a fraction. So I have minus 1 plus sine square of x, and then denominator is sine of x. So what did I do? I just did algebra. Next, in the numerator, I'll have, so I still have a fraction. I have minus cosine square of x and sine of x. So what did I do? I did Pythagorean. Let's see if that's going to be happy. That's fine. So minus cosine of x, we said to separate it, and then times, let's see if it accept this one. No. Let's see if I can make a fraction separately so it doesn't run in the first one. Cosine of x over sine of x. So what did I do? I just did algebra. Let's see if it is happy with that one. So that's fine. Now I have minus cosine of x, and cosine over sine is cotangent of x, and that is my quotient identities. Quotient, cosine over sine, let's remind ourselves. Cosine over sine is just cotangent, and that's what we did here. And let's see. So then we are done. Let's try another at this. Okay, 1 minus cosine of minus x over secant of minus x minus 1. We want to show that that is same as cosine of x. So what do we remember about odd even identities? So we have these odd even identities, the main part here. What does that do? Well, cosine of minus x, secant of minus x. Do we remember that these are even functions? So it's as if this minus is going to evaporate. Doesn't matter if inside cosine you have plus or minus, something is the same quantity that comes out either way. So 1 minus cosine of x, and the denominator is just secant of x minus 1. No, minus 1. So what did I do? I applied the odd even identities. Good. Next, out comes just a simple cosine. Why is that? Well, let's remember that secant is 1 over cosine, and somehow if we write 1 over cosine, let me just write it on paper for you. Perhaps it's going to be a ton more visible as to what is happening here. It's nearly trivial identity. So so by now we have 1 minus cosine of x over secant of x minus 1. We want to show that that is same as cosine of x. Well, remember, this is 1 minus cosine of x over secant of x minus 1. We are starting from left, and our marching order is to go from left to right for whatever reason. So go from left to right. The next problem could ask us to go from the right to the left, perhaps a little bit more involved. At any rate, this is 1 minus cosine of x, and this is 1 over cosine of x minus 1. So if you manage to print or type a fraction in a fraction, we'll see if the software will like it. And then this is going to be 1 minus cosine of x. Now I take a common denominator, cosine of x, 1 minus cosine of x. And at this stage, it's just algebra. This is 1 minus cosine of x. Numerator, denominator is you multiply by the reciprocal of the denominator. So of course these two cancel, and you are left with cosine of x. Or very lucky, you can come up with another sequence of actions to do exactly the same thing. So choose your favorite steps and move through, and let's see. So we come back to let's see, we are we were here. So I have a fraction, numerator with is 1 minus cosine of x, denominator I have a fraction in the denominator. Let's see if that works. 1 over cosine of x, and then minus 1. So what did I do? I used the reciprocal, because for secant I wrote 1 over cosine. So is that fine? No problem there. Now let's go ahead and try to see if the software will be happy. We simplify this thing. When we simplify, it's 1 over cosine over 1 minus cosine, the whole thing over cosine, and if you simplify it, you get cosine. So let's see if we can bypass typing a little bit, and if that is okay with the software. Is that fine? Well, yes. So we didn't need to torture ourselves typing all of that. We noticed that from here to here, that was all algebra and the whole thing. So from here to here, this is all algebra, and we could just indicate that from one place to another place, all we did was just that. And okay, so it's the same. The negative angle identities are not so significant as identities in themselves. Rather, it's applications elsewhere that is significant. Meaning, in a mathematics textbook, you almost never see, in the context of any problem, somebody writing cosine of minus x or something. It's going to look weird. Because the objection would be, why didn't that person already simplify this? Why didn't he already apply odd-even identities? So what we are doing here is just practicing this concept. Don't expect this to show up over and over again. But it does show up in the context of other problems you are going to see in calculus, all the way through all the calculus classes, and then higher up classes. The issue does come up, so you want to make sure you are comfortable with those. So perhaps we'll have separate lectures for these, but for now We are just applying them in the context of identities. So until next time, good luck and God bless.